Welcome to Module 204H on reversing magnetic starters. In this module, we have four different objectives in which we look at how a reversing motor starter works and what are some of the different components that we see that are unique to a reversing motor starter. We're going to start by looking at the basic operation of what a reversing motor starter does and how it does it. The way that a three-phase motor operates is it is reliant on each phase peaking at a different time. They are all separated by 120 electric degrees. What this also means is they have different magnetic strengths at different points in time. What we find is that there is a magnetic rotation happening between each one of the phases. In order to reverse the physical rotation of a three-phase motor, I also had to reverse the magnetic rotation within that motor. And I do this by interchanging any two phases on the motor leads. What this results in is a reverse magnetic rotation, which results in a reverse direction of my rotor. Our reversing motor starter does this for us automatically, and in order to accomplish this, we do need to make sure we have certain components that are put together. First, all of our reversing motor starters will have two contactors put together. One contactor will be for the forward direction, the other contactor will be for the reverse direction. Between these two contactors is a physical interlock. It's called the mechanical interlock, and its purpose is to make sure that both armatures cannot be physically pushed down at the exact same time. We also require two normally closed auxiliary contacts that we're going to use for our electrical interlocking, and since this contactor is controlling one motor, we only need to have one overload device. The key to achieving this reverse phase rotation is all in how we wire up the starter. In NEMA starters, we have to apply the wiring ourselves, but in IEC starters, they do have blocks that do facilitate that wiring for us. When we look at a forward contactor, it is wired as normal. L1 will go to T1, L2 will go to T2, and L3 will go to T3. When it comes to the reversing starter, the contactor will tap off the L1, L2, and L3, but as we go from L1 through the reverse power contacts, that line comes back to T3. This effectively changes my L1 line to my T3 output. L2 will still go to the reversing contactor and be returned back to T2, so we're not changing that phase. And L3 starts on L3 and comes back to T1. This has effectively reversed L1 and L3 on our output side, which will reverse the motor magnetic rotation, which reverses the motor. When we look at the basic schematic for a reversing motor contactor, we notice that both the forward and the reverse contactors are wired in parallel to each other. The forward start button will start the forward coil, the reverse start button will start the reverse coil, and they are both connected to a separate stop button that will stop the entire process. Keep in mind that NEMA and IEC have different terminal points on both of them. While the schematic itself is fairly similar, we need to be aware of the terminal numberings between the IEC and the NEMA starters. In Objective 2, we're going to take a closer look at the mechanical interlocks on a reversing motor magnetic starter. Since the purpose of my reversing starter is to interchange two lines between line 1 and line 3, we can have a serious problem if both of the armatures were closed at the same time. Once we close both of the armatures, what we will find is that there is a direct path between line 1 and line 3, which would cause a line-to-line short. In order to prevent this from happening, we need to have a physical way to block both of those armatures from going down at the exact same time. And this is where my mechanical interlock comes in. This is placed between my forward starter and my reverse starter to make sure that there's no possible way both of the armatures can be pressed down at the same time. On my drawings, it is represented by a hatched line that is found between the forward coil and the reversing coil. In addition to our mechanical interlocking, we also want to make sure that our reversing starters have an electrical interlocking. In previous lessons, we discussed what would happen if our armature on our contactor were to be blocked. What we found is that it would cause a very high current in the coil, which could potentially burn it out. With my reversing contactor, if my forward coil is engaged and my armature is pulled down, I have a physical blockage in the armature of my reversing coil. If I were to try to energize my reversing coil at that time, I would have a blocked armature condition, which could potentially burn out my reversing coil. In order to protect my coils, I need to make sure I use electrical interlocks, which are normally closed contacts. Each coil will have a normally closed contact placed in the line of the opposing coil. My forward coil would have a normally closed contact in series with my reversing coil, and my reversing coil would have a normally closed contact in series with my forward coil. This makes sure I cannot energize both of those two coils at the exact same time. All my reversing starters must be equipped with both mechanical and electrical interlocking to prevent from line-to-line shorts or the possibility of a coil burnout. And we need to make sure the electrical interlocks are placed in the correct location in order to protect the opposing coil. In our last objective of this module, we're going to look at the 7 different control circuit sections and look at the terminal numbers that are associated with the IEC and the NEMA starters. When we talked about basic motor starters, we discussed how each motor starter circuit had 3 different sections: the start section, the stop section, and the holding section. With our reversing starters, since I have 2 different coils, we have 7 different sections to think about now. First, we're going to do a comparison between the NEMA and the IEC starters and some of the labeling differences that we see. With my reversing starters, since I have 2 different coils, I also need to have 2 different holding contacts. On my NEMA, my forward holding contact is found between points 2 and 3, and my reversing holding contact is found between points 4 and 5. On my IEC device, both of them are found between 13 and 14, so there is no difference in numbering between my forward and reversing contactors on my IEC reversing starter. Keep in mind, I have 2 starters side by side, so I should know which one is forward and which one is reverse. On both these types of starters, my electrical interlocking is found in the same location, in series with the opposing coil. On my NEMA, I can find it between points 3 and 6 for my forward coil, and between points 5 and 7 for my reversing coil. On my IEC, I find it between points 14 and A1 on both my reversing and forward coil. The last difference to look at between these 2 starters is where my overload contact is. On my NEMA starter, it is found after the forward and reversing coil and before line 2. So both of these coils will be operated by the same overload contact. On my IEC starter, I find it at the beginning line in my stop circuit. So my line 1 will first occur through N95-96 on my overload, and then it will continue on towards the rest of my control circuit. This brings us into discussing the 7 different sections of my reversing diagram. The first section is my general stop circuit, where I find my overload contacts as well as my stop circuit. Keep in mind, the only time I see overload contacts here is if I'm going to be using an IEC starter. My general stop circuit is intended to stop everything inside that for both forward and reverse function. My second section is my forward stop circuit. In this part here, I can put in any device which I can use to stop the forward rotation of my motor. I also have a reverse stop circuit, in which case I can put in devices here to stop the reverse function of my motor. Next is my forward start circuit and my forward holding circuit, which are in parallel with each other as they are in most other contactors. I also have a reverse starting and a reverse holding circuit, and this makes up my 7 different sections: my general stop circuit, my forward stop circuit, my reverse stop circuit, my forward start circuit, my forward holding circuit, my reverse start circuit, and lastly, my reverse holding circuit. Most motors are not built in such a way that they can handle going directly from forward function to reversing function without at least stopping or slowing down, which is why most of my control circuits will utilize a common stop button, and I would not be able to go from forward to reverse without first pressing the stop. However, some motors are built in such a way that they can handle going from forward to reverse and back again without having to stop first. In order to do this, I need to utilize my forward stop circuit and my reversing stop circuit, and I also need to have a normally open and a normally closed button in both those circuits as well. What this allows me to do is, as I press down the forward start button, it would automatically open up the reverse circuit, thereby disengaging the reverse coil if it's operating, which closes the reverse interlocking contact. Now that my motor is working in a forward function, My forward interlocking contact would be open until I hit the reverse start. When I press the reverse start, since it is interlocked with my forward circuit, it would open up the stop in my forward circuit, which would de-energize my forward coil, and it would allow me to energize my reversing coil. With this type of system, I can go from forward to reverse without having to hit anything else except for the forward button or the reverse button. You've reached the end of 204H. To review, you should be aware of the differences between a reversing contactor and a standard contactor. You should know the three types of interlocking that we have within a reversing contactor, which is our mechanical interlock and our electrical interlock that are found on every single reversing contactor. And you should also be aware that we can incorporate push button interlocking in there as well. You're expected to know the differences between the NEMA and the IEC number patterning and be able to recognize the differences in each one of those drawings. You should also know where to find the overload contact in each one of those drawings. Make sure you return to Blackboard, complete the self-test, and do a review of modules 204F, G, and H, and then you can complete the review test for S4-2.